Hello guys, I'm testing out a new tail section for my Joker 3DD. It's just a lighter lighter weight variant of what's already been established. I'm using a T-Rex 600 tail hub, which is pretty much what they use on the 700 for weight reasons, and this is Thunder Tiger yoke. And it's just kind of the stuff I had laying around. I know it'll work because it works on the 700. And instead of using the Plettenberg motor, I happen to have a core that I needed to rewind, so I rewound it so I'd have about a 690 kV. And overall, the weight of this hub is about 220 grams. And for reference, the stock hub here, I'll actually pull it out for you. I got it in my box. This here weighs 175 grams. This has no motor, and then there's a torque tube, and then there's also the motor. So you've got 170 plus about 150 grams for the motor, plus about 56 grams for the torque tube. All that adds up. This weighs 220 grams, and that's it. And the harness weighs about 40 grams. So, I mean, you save over 100 grams on the helicopter, and that's a pretty decent chunk of weight that you could put into something like a battery. But and again, you know, this helicopter, I'm not flying it for utility. I mean, if I was flying it for utility, I'd want, you know, all of this beef and bulk. You know, it's necessary. I mean, but I'm flying it for 3D, so I mean, it could be a little lighter weight. It doesn't have to be as slop-free, but you know, within reason. And the shaft I used for the motor, basically I pulled out the Cora shaft and I used the stock 3DD shaft here, and then, you know, pretty much exactly like this. I have the end with the short flat at the end of the motor, and then I'm not using the other flat in the shaft. I had to regrind one here at the tip and another one further down for a shaft collar that's inside of the motor, inside of that groove there. So there's the shaft collar, and I wanted the set screw to go into the flat. That way the shaft, there's no way it could slip in, because that would be bad. And of course the groove for the tail rotor hub, for obvious reasons, for it to sit where it needs to sit. Okay, and that's pretty much it. I have 3 18 gauge wires running the phase wires all the way down to the main frame, because I want the ESC in the main frame, and the batteries back there too. So, you know, so the weight is all in the main frame, and the tail boom's as light as possible. I have a little test rod here to control the tail pitch manually. So let's go fire this thing up. Alright, let me get situated here. Sorry about all of this, but I'm going to turn the knob. You're going to hear the motor turn on. Alright, the motor's on, so let's start looking at it. And the motor's gonna bog because the battery's not the best, and the ESC is only like 20 amp ESC. You really need a 80-ish amp ESC for this. But I'm more doing a load test on the motor to make sure it's not going to burn up, because I did rewind it. It seems to be doing really well, actually better than it did whenever I got it from Contronic after rewinding it. Oh, these are 105 millimeter tail blades. And just for the record, the tail motor shouldn't bog like this in actual operation with a good ESC and a good motor. Actually, a good ESC and a good battery. It's got a good motor. Alright, let's go check out what we got here for temperature. Nothing, which is great. That's how it should be. Well, I expect some temperature from the ESC, and the battery is definitely getting a little warm, which is reasonable. But it's not a, it's a salvaged battery for testing only, and the ESC, it's whatever. But as you can see, it does work. Nothing's coming apart yet. So whenever I get it all together and ready for a test flight, I'll let you guys know.